So, hello students. Am I audible to all? कोई एक confirm कर दो.
Yes, sir.
Okay. So, shall we start the online doubt sessions? So, wait, students are joining. Let them join first. Still, students are joining one by one. Chat box. So, is this your first doubt session, right?
Yes.
Okay. So, अभी तक कितने session हो गए? How many sessions are done? The main class. Have you attended anything?
Yes. 5 sessions.
5 sessions. Sorry. कोई एक confirm कर दो please. So if someone has any doubt, so they can drop their message in Dropbox. Then I'll continue one by one. So you can ask a doubt there, and I'll start explaining. So this is an open doubt session. If any students have any doubt, they can clarify here. So anybody has any doubt, they can start asking the questions. They can just drop the question in the chat box, and I'll continue one by one. Or if you don't have any doubts, so I'll present one presentation. If only you don't have any doubts, people are still joining.
Excuse me, sir.
Yes,
Uh,
Janvi.
Sir, I have one doubt
Please.
regarding the final examination that we will be having.
Okay. So
Like after the
let me
completion
clear
of
one thing.
this.
Okay, Janvi. Let me clear one thing. So this is a doubt session regarding your syllabus. So I cannot tell, or I don't have any information regarding the dates and related to your tentative date sheets and examination. So if you only have any doubt regarding any subjects or any conceptual things, that doubts only clear will be here. No doubts
Okay,
will be
sir.
cleared for related to your exam sessions, exam date sheets, exam pattern, nothing. You can only ask your doubt sessions related to the subjects. So if you guys don't have any doubt, so I'll present the presentation on nanoparticles, synthesis and its characterization. So shall I start? Just give your consent in the chat box.
Yes, sir.
Okay, cool. So students are still joining. Just wait for a few more minutes and I'll start. Okay. So I think let's just join. Share the presentation. Totally 99 students are here. Okay, Devi Shri Sumesh. What safety concerns are associated with the use of nanoparticles in medicine? Okay, we'll clear your doubt. Just wait for a few minutes. Students are still joining, so they will also get to know them. Nasreen Najib, please just mute your mic.
I have, sir. I
Sorry.
have done it.
Okay.
You want me to mute it?
Yes, yes, yes.
Okay.
If you have any doubt, just drop your doubt in chat box session. Then I'll start from there. Students are still joining one by one, so just 109. So let's start the presentation first. Let me share my screen. So my screen is visible, right? Just confirm once. My screen is visible to all. Okay, okay, guys. So let me introduce myself first. So myself Ankit Malik from IIT BHU, a PMR fellow. So here I'll be taking your biomedical nanotechnology doubt session. So in today's session, we'll know about nanoparticles, its synthesis, its characterization, and its data processing of some of the characterization things. Nanoparticles. So here we'll cover mainly four topics: introduction to nanoparticles, methods for synthesizing nanoparticles, its techniques for characterization, and data processing of some of the nanoparticle-based experiments. Wait, got some request. Students. So nanoparticles. Nanoparticles. You guys are know that nanoparticles below from the 1 to 100 nanometers are known as nanoparticles. So they can be made of a variety of nanomaterials which are incredibly small. They are too small to be seen with the naked eye and are only visible with advanced microscope. Nanoparticles exhibit unique and often enhanced properties due to their small size and high surface to volume ratio, which can differ significantly from those of their bulk counterparts. So these structures can be engineered from a variety of materials, including metals, metal oxides, polymers, and many more. So these properties of nanoparticles are strongly influenced by factors such as size, nanoparticle shape, nanoparticles composition, and its surface characteristics. So as a result, they have found applications in various fields like in medicines, electronics, energy, and material science. So here we'll only cover for nanoparticles in material and medical sciences. I think I've got some requests. So earlier there are different types of drug delivery system. Like conventional, we have mainly we have three delivery systems: conventional, controlled release, and nanomedicine based drug delivery system. So earlier we used to take ointments, tablets, capsule, and syrup, which have very low bioavailability. Then for its controlled release, due to a sustained release, we synthesize hydrogel, erodible materials, polymer matrix, and degradable materials. And now, nanomedicine is target specific, which transport drug to the affected areas without damaging healthy cells. So, like nanomaterials like gold nanoparticles, carbon nanotubes, liposomes, and dendrimers. So basically, there are three types of nanoparticles: polymeric, inorganic, and lipidic based. Wait, let me. Nobody joined it. So there are three types of nanoparticles: the polymeric, inorganic, and lipidic based. In polymeric nanoparticles, we use some kind of polymers like chitosan or TPGS or any other kind of things which can enhance this sustained release or control release drug delivery systems like a polymersome, dendrimer, polymer micelle, and nanosphere. And in inorganic, we use some inorganic materials to synthesize characterization of nanoparticles like silica nanoparticles, quantum dot, iron oxide, and gold nanoparticles. And in lipidic based, there are some water and oil in water emulsion kind of things are prepared in lipidic based nanomaterial like liposomes, lipid nanoparticles, emulsion. One example of lipid nanoparticle is solid lipid nanoparticle. This one phase is solid and what is lipidic. So both are mixed with each other. So, solid lipid nanoparticles will be prepared. So in next, wait, someone joined. So now properties of nanoparticles. So I have all this divided into four categories like targeting ligands, surface chemistry, its composition, and physical properties. So in targeting ligands, there are some like nanoparticles are required to target some ligands in body or in human body or in a living body. So basically target small molecules, some nucleic acids, protein peptides of the body, and antibodies. And surface chemistry basically depends like the nanoparticles is of positively charged or negatively charged. It could be negative, it could be positive. Wait, I've got some request again. So in a composition, there are different type of composition in nanomaterials like quantum dots, metallic, dendrimer, viruses, micelles, polymer particles, and liposomes. And in physical properties, it could be of many types. Like it may be cubical, it may be spherical, it may be of road shape, it could be in triangle shape, and it may have some rigidity, some different mechanical strength, some magnetic properties also, and it may have some different roughness, different you can say like okay, roughness and porosity. Wait, I've got some request again. 117. So there are three types of method of synthesizing nanoparticle. One is chemical synthesis, physical synthesis, and biological synthesis. In chemical synthesis, basically we use some reducing agent to convert metallic ions to metal atoms. Like in if in case we suppose we'll have to prepare silver nanoparticle. So in silver nanoparticle, we'll take some silver nitrate usually we take, and it contains of silver ions. Then we use some reducing agent that will convert that silver ion to silver atom. So in this method, synthesis of nanoparticles, it could be chemical. Wait, so Sushmita Bhaskar. And in physical synthesis, we use some physical properties of anything like laser ablation. Mostly we use laser ablation technique in for synthesizing nanoparticle via physical synthesis. Then biological synthesis. In biological synthesis, nowadays it is also called as green synthesis of nanoparticles. So in this we can use plant extracts, some microorganisms like fungi extracts, bacterial extracts, like different kind of things. Then that method of nanoparticle synthesis is elaborated in some various ways. I think someone's mic is on. Bhumika Thakur, just mute your mic. So here in chemical synthesis, we can say one chemical reaction is going on. Then we use some coating process, or we use some lipid or any polymer or anything, any reducing agents. Reducing agents like ascorbic acid, and there are different types of reducing agents are there. In physical method, we'll use some external force or external things to prepare the nanoparticles. Like in physical method, we use laser ablation, which mix metal and solvent there. Then it will, in physical method, there are different kind of shapes will be there, like root, triangle, spherical, cubical, different kind of different shapes will be there. And biological synthesis, I already told that bio microorganisms, bacterial, fungi, and plant extracts are used in biological synthesis. Indulkar. So these are some examples of nanoparticle synthesis. In physical methods, we have high energy ball milling method, inert gas condensation, pulse vapor deposition, laser pyrolysis, flash spray, electrospraying, and melt mixing. And in biological methods, microorganism assisted, as already told, that different fungi, bacterial, and plant extracts are used, and biotemplates assisted biogenesis and plant extract assisted biogenesis. Mainly, we use this is used for metallic nanoparticles. And in chemical methods, exfolial synthesis, microemulsion techniques, hydrothermal synthesis, polyol synthesis, chemical vapor synthesis, plasma enhanced chemical vapor deposition. So now proceeding further. So now we'll discuss about nanoparticles characterization techniques. So we have different types of characterization techniques are there, like UV visible spectrophotometer, dynamic
Hi,
electron.
sir. Can you please reshare? Sorry for interruption, but we cannot see your PPT actually.
Okay, you should have told me earlier, na. So from which slide you are not able to see my slides?
So since 2 minutes, your screen was not visible.
Okay, you should have told me. Wait. Let me reshare my screen.
So actually,
We can see your screen and everything. I mean, we can see all the slides as you're speaking. So the issue could be with the participants, but I request if you can make it a full screen because it's really tiny for us to see.
Okay, okay, I'll share my entire screen. Wait.
Now nothing is visible.
Excuse me, sir. Can you hear
Yes,
me?
Devshri. Anji.
Also, my net is not very strong, so can we get
Oh, it
this PPT?
might be an issue with your
Yeah.
internet connection.
No, can we get this presentation that you're showing?
I'll share this presentation also. Wait.
Okay. So where will you share it? Can you share it via email? Because I'll be leaving this meeting. I don't have
I'll
access.
share one YouTube link. Then in that in YouTube link, this presentation is there. So at last, I'll
Okay.
share the link in chat box only. Wait, let me reshare my screen. I don't know what the issue is. So now is it visible to all?
Yes.
Is it visible now?
Okay.
Huh. So now we'll discuss about different methods of characterization of nanoparticles. So we have UV visible spectrophotometer, dynamic light scattering, or in layman language we can say zeta sizing or particle size analysis, zeta potential measurement, FTIR Fourier transforms, infrared spectroscopy, X-ray diffraction, scanning electron microscope, transmission electron microscope, HRSEM, HRTEM, energy dispersive spectroscopy, AFM atomic force microscopy, inductively coupled plasma spectroscopy, and Raman spectroscopy. So we'll lead by one by one. So first we'll go with UV visible spectrophotometer. So in this that wait, I think I got some request. So UV visible spectrophotometer. So in UV visible, absorption of UV or visible light is measured by chemical compounds. So here we can use, as you can see, so this is a UV visible spectrophotometer. There's one cubit is there, and that we will put our samples in liquid sample, maybe like 2 to 3 ml. Then we'll put our cubit here in this section. Then UV laser came from this section and will cross the liquid sample and will give the absorption and wavelength at different wavelengths. Still some students are coming. So next is dynamic light scattering. Is have you ever heard about zeta sizing or particle size? Like how do you know that what is the particle size of your nanomaterial? So for that we'll use dynamic light scattering, DLS. So basically we use this Malvern zeta sizer, and this is the particle size analytical sample cell Here we can put our sample. 1 ml sample is placed here in this cuvette. Then this 1 ml cuvette is put it into this Malvern zeta sizes. Then this kind of result will appear. So as you can see, this single peak is there. So it the result came in average. Like different there are three types of particles. Like size is 76.22 as you can see here, and intensity is 100%, and standard deviation is 29.19. So the result quality here is it is good. So the ideal size of nanoparticle is from 1 to 100 nanometer, and PDI, this polydispersity index, it must be near to 0.100. It shows how uniformly it is distributed in the nanocomposite or any nanomaterial or any suspension. So this is zeta potential measurement. In zeta potential measurement, we use the same instrument Malvern, but only one instrument is there which have this different kind of qubit system are there. So zeta potential measurement is also came in these things. Like zeta potential came in average like 49.9 here, as you can see in this results. And there is some range zeta potential value, that its zeta potential shows how stable your nanomaterial is, how stable it is, like whether it is unstable or stable. This we can confirm by zeta potential measurement. It is a charge developed between the solid surface and liquid medium. So there's a some scale is there. So from minus 10 to plus 10, if your zeta potential, if your nanoparticles have the zeta potential value from minus 10 to plus 10, so it is highly unstable. It will not be in the same position or same scale or in same potential from throughout your like week or 10 days. It will get unstable. If your nanoparticles have the size range between minus 20, either it is in minus, either it is in 20, it must be it must be more than minus 30 or plus 30 to be stable. Like from minus 10 to plus 10, it was highly unstable, and in minus 20 to plus 20, it is moderately stable, and from minus 30 to plus 30, it is sorry, it is moderately stable, and from minus 20 to plus 30 is relatively stable, and from more than minus 30 and more than plus 30, it is highly stable nanoparticle or nanomaterial. So moving forward, this is FTIR, Fourier transform electron microscope, sorry, Fourier transform infrared spectroscopy. So here we can use powder sample. So there are two type of FTR and ATR is also there, attenuated transfer things. Then liquid sample, solid sample are required. First we have liquid sample, then that from liquid sample we freeze dry that sample in solid sample. Then in this KBR pellet is made, a transparent KBR film is prepared here, and there are some common, the wave number ranges from common functional group. So this folic acid, we have example of folic acid and trypsin folate. So as you can see, there is some range is given like 3500 to 3200. If your peaks came in this range like 3200 to 3500, so that means that OH and NH stretch are present there. If 32 to 28, it confirms the presence of CH stretches are there. Likewise in here 2921, one peak is there, small peak, like for example 29211 peak is there. So it came in this range CH stretch, so which confirms it has CH stretch, CH functional group here. Likewise for example we can see like 16891 peak is there, so it confirms the presence of like 16 like C double bond O stretch are there. Likewise 838, one peak is there, so it confirms the presence of C double bond C and aromatic ring or CH wakes are there. So likewise same in chitosan folate, some different peaks are there which confirms the presence of functional group in that nanomaterial or any chemical compound. So the next is XRD, X-ray diffraction. So basically in XRD, we used to see whether your compound is like in amorphous phase or in crystalline phase. If the peak is sharp, like we have example of some nanoparticles, like it gives a broad peak, like in A, B, C, and D. In A, it gives broad peak. So broad peak means it's amorphous in nature. The substance, that compound or that chemical is amorphous in nature. Likewise in B, it also gives broad peak, so it also confirms that it's a it is a amorphous compound or amorphous chemical. Likewise in C, it gives various sharp peaks at 31.8, 45.5, 56.4, and many more. So it confirms that the material is crystalline. There's one amorphous also there, amorphous nature is also there. So one broad peak is also there. Likewise in the same, some sharp peaks are there which confirms the presence of crystalline nature is there in your nanomaterial. So which types of sample are required for XRD? So drop casted film or powder form are accepted for this XRD diffraction method. So this is an instrument for XRD. So there are two types of XRD instruments are there. One is BT XRD, one is HR XRD. So benchtop XRD and high resolution XRD. So this is SEM, scanning electron microscope. So this is an instrument for SEM. This is a sample preparation method. I'll show you. So here first we'll take the glass slide or substrate, in which basically we use glass slide. Then we'll drop cast our nanomaterial or liquid sample. Then it will evaporate the solvent, and only your nanoparticle or nanomaterial will be stick there. Then at last substrate, only substrate and your nanoparticle will be stay there. So this is a sample holder of SEM in which we stick our glass slide on this. Then gold coating will be there, carbon coating or gold coating, whatever you can say. So both the coating are used. Sometimes they use gold coating, sometimes they use carbon coating. So there are some optimized SEM images of nanoparticles, as you can see. It's highly polydispersed, uniformly distributed. See how clearly it comes, like how spherical it is. This is EDX, energy dispersive spectroscopy. So it confirms the which kind of elements are present in your nanomaterial. So it is conjugated with SEM instruments or TEM instrument. Both the instrument have this EDX. So likewise in A graph you can see some Ag silver peaks are there, chlorine peaks are there, copper peaks are there, carbon are there. So it confirms the presence of element in your nanomaterial. Likewise in second graph, it shows carbon peak, oxygen, silver, copper. So it confirms the presence of whatever the element present in your nanomaterial or nanoparticle. It shows that peak. So HRTEM, high resolution transmission electron microscopy. So this is the visualization of HRTEM instruments. It works on high voltage electron beam. So one electron gun is placed there which produce the electrons, and it through the vacuum tube and produces the results. So in TEM there is one copper grade. We in SEM in SEM we prepare our sample on glass slide, but in TEM we use this copper grade to prepare our sample. So in copper grid we drop cast our nanomaterial liquid sample. Then it will we have to wait till it dry. Then after drying, see, as you can see here, some dots are there. So these are the evaporated nanomaterials are there. Then we can use to see this TEM grid through electron, yes, through TEM. So these are some optimized nanoparticles images of TEM, as you can see. Both are less than 100 nanometers. There are some uniformly distributed TEM images nanoparticle. Now AFM, it is atomic force microscopy. This is the instrument, and AFM sample preparation is same as of like we've prepared for SAM. So in AFM there's one cantilever is moving on the sample, as I'll show you. So you can say this is your sample, and one cantilever is there. It moves through on your it moves on your sample, and it will give results like its mechanical strength of your nanoparticle, its magnetic property, its physical strength, and its adhesion strength of your nanomaterial. So it gives results like in 2D and in 3D images. So as you can see, this is a 2D image and this is a 3D image. How intense or how deep it is. Just see how uniformly distributed nanomaterials are there. So these are the things. So I'll share you this PPT.
Hello.
हाँ जी एक वेट हाँ जी now you can ask your doubts.
Sir, asked that I mean मेरा यहाँ ज्वाइन किया है तो कोर्स जो है वो जो मतलब हम जब डेली क्लासेस अटेंड करेंगे तो अभी आप जो स्पेक्ट्रोस्कोपी के बारे में वगैरह सिखा रहे थे तो फिर वो और ये इन दोनों में मतलब ये भी पढ़ना पड़ेगा कि एज एन एम जस्ट आस्किंग दैट
हाँ जी क्योंकि it comes in characterization. So spectroscopy is used for characterization of nanomaterials. So spectroscopy is must. So उसके principle, their sample processing, their peaks.
अच्छा
their
मतलब
results.
एडिशनल कॉन्सेप्ट्स जो है वो कवर किए जाएगा क्लासेस में
हाँ जी. So this is mainly for doubt session. If you have any doubt related to your subjects, related to your main course, you can ask here. So this session is for that purpose only. So I'll share this PPT also.
ओके
So if you have any doubt related to this or any related to your coursework only, you can ask in chat box. Anyone?
Sir,
हाँ जी.
sir, you are telling about the different kinds of instruments used to characterize nanoparticles.
हाँ जी. Yes.
If you want to see, you have to use SEM and TEM.
Basically, SEM and TEM is the most widely used to see the your size and shape of a nanoparticle. So
Size
SEM,
and shape.
huh.
Okay.
So SEM
So
is
this
used
is
to visualize through like 200 nanometer and more than 200 nanometer, and TEM is used to see the nanomaterial through like in small size, like from one nanomaterial one. So, wait. Some students are
one. Yes.
joining.
And this AF atomic,
Force microscopy.
yeah, what is that? Say atomic force microscope.
हाँ
So
जी.
what it is going to detect? We can see it, or it will give us a graph, sir. This AF
See, SEM and TEM will not give you any graph, or even AFM will not give you a graph. SEM and TEM will show you the image, the
image.
realistic image of a nanoparticles, how it is in
Okay.
shape, how it is in size, how uniformly it is distributed in your suspension. Same likewise AFM. AFM give it's your like adhesion strength, mechanical strength of a nanoparticle. It shows
Oh,
you
okay.
the results, like the real image as you can see in any photograph your mirror image. This kind of image will be given by Samentem. No graph will be given in Samentem. And in EDX it will give you graph, like it will show you the elemental graph. If copper is present, it will give you a copper graph peak,
Oh.
copper peak. If
Oh.
silver is present, if magnesium is present, if it will give you the elemental peak there. This EDX is present as attached with SEM and TEM instrument, but SEM and TEM individually will not give you any graph. It will show you only image.
Oh, thanks a lot, sir.
As I
So,
showed
STEM
you.
and TEM is for image, and all the other things for characterization.
हाँ
What
जी.
kind of metals are there? Whether it is amorphous or crystalline. So, in order to know more about, nano, we have to use these instruments,
Yeah,
right, sir?
exactly. Yeah. There is one
Thanks a lot.
chronology. There is one chronology we use here in nanotechnology. First, we used to characterize through AFM. If it came spherical, it came like uniformly distributed. Then we go for SEM. And at last, if all goes well, then at last we'll do TEM transmission, HR TEM, high resolution electron microscopy. It will give you in a scale of 1 to 100 nanometer. I'll show you the result
Okay.
once again. Wait.
Yes, sir, one more thing. So, how can we be sure that a nanoparticle is pure? It is not contaminated with other dust and other, elements which are not of our interest. Now we are creating some nanoparticles. So, which test will just confirm whether our nanoparticles are pure?
Hmm. So I have discussed about this FTIR, if you heard.
Okay.
So in FTIR, wait, I'll show you the presentation. I'll share.
Sir, one more thing. If you could please tell us regarding preparation of the nanoparticles, which all things we have to do in a serial manner. All the things we cannot do, na? So
There's
which
one
all things are
chronology.
important?
There's one chronology. I'll discuss that. First, I'll
Yeah, yeah.
clear that out of Nasreen Najib first. I'll come to you, Sandeep. So is my screen is visible now?
Not yet.
Not visible.
Not visible.
Yeah, now it is visible.
So you're asking that how could you know that your nanomaterial or your nanoparticles is contaminated or not, right?
Yes, sir.
So
Yes.
for that we use FTIR, Fourier transform infrared spectroscopy. So whatever the chemical, whatever the material or compound or chemical you have used in your synthesis of nanoparticle, that only peak will come here. If additional peak is coming, whatever which you have not used any chemical in the preparation, that additional peak will come. Likewise, is OH NH stretches there, C triple bond N, C double bond O, C double bond C. If additional peak will come, which you have not used in your synthesis of a nanoparticle, so that contamination is confirmed from this FTIR spectroscopy. Still, some students
Oh,
are
thank you, sir. Okay, thank you.
okay. So Sandeep, you are asking about chronology, right?
Yes, sir.
My screen is visible now.
Yes, it is visible.
So Sandeep, like after preparation of nanoparticle, the first step, the first characterization, what we do is UV visible spectroscopy. If in case, for example, we have prepared silver nanoparticle, so whether it is prepared or not, in silver nanoparticle, the silver ions is converted into silver atoms. That silver atoms give it specific peak at near about 500 something. So that if in UV visible spectroscopy, if peak is coming near that range, so that nanoparticle is prepared. Understood? So then after UV visible spectroscopy, then we'll go for dynamic light scattering, particle size. So first we'll do this UV visible spectroscopy, then we'll go for this dynamic light scattering. Dynamic light scattering shows the particle size. Wait, I'll show you the results also. Huh. So first we'll do this UV visible spectrophotometer. It will give you the specific peak, whatever you have prepared, whatever the metal, whatever the polymeric nanoparticles you have prepared. It will give you a specific peak of that particular compound of particular metal ion. So then after UV spectrophotometer, we'll go for this dynamic light scattering, particle size. So it will give you the particle size as it is showing here 65.18. So basically we know that the nanomaterial are below 100 nanometer ideally. So it is giving 65.18. That means nanoparticles are prepared, and PDA also 0.146. It is also uniformly distributed. So first we'll go UV spectrophotometer, then we'll go for dynamic light scattering. After confirmation of that the nanoparticles are below 100, then we'll go further for zeta potential. Then we'll go for zeta potential, then FTIR, XRD. So I have prepared this PPT in chronology only. Sandeep.
Okay, sir. Yeah, yeah, yeah.
So
I
this
could follow.
presentation is made in chronology. First we'll go for UV spectrophotometer, then dynamic light scattering, then zeta potential, then FTIR, then XRD, then SEM, then HR, then TEM, then HR TEM, then EDX, then AFM, then inductively coupled plasma and Raman spectroscopy. This made is in chronology only. So you can refer this for chronology.
Okay,
The
sir.
series of characterization of nanoparticles. So anyone else can ask. You can also ask in this chat box also. Without giving sample to any technique, how will we check its purity? Without giving sample to any technique. So Neha, can you please unmute your mic and just discuss it with me? I didn't get your question. Without giving sample to any technique, how will we check its purity?
Yes, sir.
Neha,
Means without giving sample
Hanji.
to TEM, STEM or any other technique,
Hmm.
sample of nanoparticles, how we will check the purity? How will we come to know that it is a pure nanoparticle?
So the basically first thing we have to do is UV spectrophotometer. So it
Okay.
will give a sharp peak at specific. I told now that like if we prepared silver nanoparticle, so silver nanoparticle
Yes.
peaks came from 430 or 500, nearby 430 and 500. So if peak is coming between
Yes.
that range, so the nanoparticles is pure before giving to cement time.
O-
If that peak is coming
Okay.
properly in that range, that means your nanoparticles is completely pure.
Okay.
Okay, then
Thank you.
Bhumika Thakur, how to determine zeta potential of any nanoparticle? Bhumika, you can unmute your mic and ask. Bhumika, hi.
Actually, I have a problem. So here's hearing voice. So that's why I'm not unmuting.
So I think your internet connection is not that good. So you can unmute your mic. I'll explain. So how to determine zeta potential of any nanoparticle? So I told now that zeta potential is basically for its stability. How stable your nanomaterial, how stable your nanoparticle is. So it give the information how positively, how negatively charged it is. Wait, still some students are coming at 7:49. Some students are. So Mika asked about zeta potential measurement. So liquid sample is given in this particular different types of. Is my screen is visible to all? Hello.
Yes, sir.
Yes, sir.
हाँ तो Z. Hmm. So in zeta potential measurement, we give in liquid sample is given in liquid form. 1 ml sample is enough for a zeta potential measurement. So in that cuvette, like was in dynamic light scattering, this normal cuvette is there. See, nothing, no electrode is there, nothing is there. It will only give the information about particle size and PDI. Like in zeta potential, some electrodes are there in a cuvette. So some positive electrode, negative electrode is there in single capillary. So both are like attract to negatively charged oppositely charged electrodes, so negatively will go towards positive and positively will go towards negative. So it will give information about it will give results in minus and positive. So it must be in on more than minus 30 or more than plus 30. So if your nanomaterial have the zeta potential value more than minus 30 or more than plus 30, it means your nano material or nanoparticle is highly stable. If you can keep your nanomaterial in room temperature or whatever the condition you have prepared your nanomaterial, it will be like that only. If after 2 months or 3 months also you can check your zeta potential, it will be highly stable. If only if it is its value zeta potential value is more than minus 30 or more than plus 30. So this is zeta potential measurement. So
So I have a question.
Anji, please.
Will zeta potential vary with the concentration? Since you told we put 1 ml, so what should be the concentration concentration of the nanoparticles in it?
No, irrespective of concentration. If whether you put 1 ml in zeta potential measurement, we only there's a limit of 1 ml only, and there is no any. It by the way, it is irrespective of concentration. Whether you give 1 ml or you can dilute it, it will still come the same. Value will be still same. अगर आप उसको dilute करके भी दोगे, तो still the value will came same. If it is stable.
Okay.
हाँ जी. Anybody else? Still students are joining.
Sir, I have one more doubt.
हाँ जी नसरी.
Sir, now in the zeta potential, you are now measuring the nanoparticle charge.
हाँ जी. Surface charge
So
of
how does it
nanomaterial.
matter? So how it is going to matter, sir, whether if it is negatively charged or positively charged? So it is going to, affect the future. Like how it is going to matter for the nanoparticle?
Okay,
How it is used for it?
okay, I'll explain you with example.
Yes, sir.
So
Thank
if
you.
we have prepared silver nanoparticle, wait, still some students are coming. Hmm. So for example, we have prepared some metallic nanoparticle. So metal have some charge. Silver nanoparticles have some charge. Hmm? Nasreen, it is an interactive session. You can say yes or no to me.
Yes.
So any metal have some charge.
Metals have charge. No, they don't have charge.
Like in silver, I'm asking about silver nanoparticle. Silver ion. Silver have some
Oh,
charges.
yeah, it will have charge. Yes.
So silver metal have some charge. So
Yes.
it is whether it is highly charged. मान लो I'll explain in Hindi for your silver nano particles पे कुछ charges हैं if in case मान और वो interact positively charged है for example कोई metal है positively charged है highly positively charged है हमारे पास उसका zeta potential value आया +30. So अब हम मान लो किसी बैक्टीरिया सिल्वर नैनो पार्टिकल्स आर बेसिकली यूज फॉर बैक्टीरियाइडल एक्टिविटी. So if highly positively charged silver nanoparticle is interacted with negatively charged, uh, wait, I'll show you with one example.
Yeah, it is going
So
to.
this is one positively charged metal, and this is
Yeah, I
some
understand.
negatively charged surface of any
Yes,
bacteria or something else. So
yes, yes.
if it is highly charged, it will got interact with that negatively charged. So
Okay.
opposite interact करेंगे एक दूसरे से. So they will got interact each other. So in this way, it will affect that zeta
Okay.
potential measurement of any nanoparticle.
Oh, so there was a question they asked in this assignment how this nanoparticle are going to kill the main bacteria, what effect it will have, whether it will have it is going to kill physically or chemically or electrostatic or like that one question was there. So
Okay.
so it is going to so what is the correct answer for this? So it is going to, use this electrostatic. This type of charge has bactericidal effect. It is going to kill the bacteria because of this charge.
हाँ जी. So you got it? You are asking or
Okay.
you are telling me?
Yeah. Thank you.
Okay.
Yes. I got the answer. So thanks a lot.
Silver nanoparticle have positive charge, so it will interact with the negatively charged bacteria membrane negatively charged होती है. So the positively
Okay.
charged nanomaterial will interact with negatively charged bacterial membrane. So in this way, it will kill the
Okay.
bactericidal bacteria or any microorganism.
Okay.
हाँ
Okay.
जी.
Thank you. Thanks a lot. Sir. Thank you.
Bhumika Thakur. So, sir, what about polymeric nanoparticles? I mean, zeta potential of polymeric nanoparticles. Okay, Bhumika Thakur. So, it depends. मान लो हम कोई नैनो पार्टिकल बना रहे हैं और वो न्यूट्रल है. दे डोंट हैव एनी चार्ज लाइक दे हैव नो पॉजिटिवली चार्ज और नेगेटिवली चार्ज और हमें उसकी बैक्टीरियाइडल प्रॉपर्टी दिखानी है. So in that case we'll use some polymers. For example, chitosan is positively charged polymer. So उस नैनो पार्टिकल पे हम पॉलीमर की कोटिंग कर देंगे. We'll coat that chitosan over that nanoparticle. So automatically by default वो positively charged nano particle हो जाएगा. अगर हमें किसी नेगेटिवली सरफेस के लिए नैनो पार्टिकल बनाने हैं, हमें पर्पस देखना पड़ेगा पहले. फॉर व्हाट पर्पस वी आर प्रिपेयरिंग द नैनो पार्टिकल्स. So if we are using that nanomaterial for any bacteria, for any organism, for any drug delivery system. So drug delivery system में क्या होता है, अगर जो सरफेस है वो नेगेटिवली चार्ज है तो हम पॉजिटिवली चार्ज पॉलीमर से उसकी कोटिंग करेंगे. लाइक इन सेम वे अगर कहीं कोई सरफेस नेगेटिवली पॉजिटिवली चार्ज है तो हम नेगेटिवली चार्ज पॉलीमर का यूज करेंगे उसकी कोटिंग करने के लिए. सो बाय डिफॉल्ट वो नैनो पार्टिकल नेगेटिव और पॉजिटिव हो जाएगा. ऐश्वर्या पाटिल, गॉट इट भूमिका ठाकुर. चिटोसन नैनो पार्टिकल्स जैसे हम करते हैं तो उसमें पॉजिटिवली चार्ज उसका पॉजिटिव जीटा पोटेंशियल आता है.
So, if we code that with negative or positive charge, won't they affect their uses?
Sorry, I didn't get you, Muskan.
So, you have said some particles in water, we can.
Muskan, you are not audible. You can ask your question in chat box.
Okay, sir.
हाँ जी. So, with atomic force microscope attraction and repulsion forces are used to identify surface topography, right? But since this force depends on both the distance of the sample and probe and also the nature of the sample at a point, how do we get a separate profile for the qualities? Okay, Niranjani Ramakrishnan. Okay, but since this force depends on both the distance of the sample and probe, इसमें AFM में ऐसे नहीं होता. AFM use a one cantilever is there. वो हमेशा उसके सरफेस के ऊपर से उसकी जो टोपोग्राफिकल स्ट्रेंथ टोपोग्राफिकल नेचर होता है नैनो पार्टिकल का वो उससे पता चलता है. So distance doesn't matter in the topography of this any spectroscopy or any microscopy of this nanomaterial. So दोनों की
That's
separate profile नहीं बनती. Both have the same profile.
Since like if like say at the surface like there is like a roughness and like certain points are more elevated than the others, then at these points the sample would be closer to the probe, right?
You're not audible. You can repeat your question, please.
Can you hear me?
हाँ हाँ हाँ.
Like what I'm saying is like if there's a roughness to the surface,
Mm-hmm.
then at particular points the sample would be closer to the probe, right? And this will like obviously affect the force
हाँ.
between the sample and the probe.
Hmm.
And like also the nature of the particle itself at like at a particular point the sample and the probe will also affect the force, right? So
Okay.
how do we like say like if there's a region of high force, like I mean high attraction forces, is it because the distance between the sample and the probe is less, or is it because of the nature of the particular point like particle at that?
Okay, got it. It's basically the nature of the nanoparticle. It depends. The distance doesn't matter.
Okay,
हाँ जी.
thank you.
So are you guys asking about assignments question? Assignments के question तो नहीं पूछ रहे ना आप लोग? You have some genuine doubts, right? So Muskan, won't it affect the uses of effect if neutral particle is coated with other nanoparticle? Muskan, won't it affect the uses or effect if neutral particle is coated with other nanoparticle? See, neutral particles उस पर कोई चार्ज नहीं होगा तो वो अनस्टेबल होएगा. गॉट इट. तो उसका कोई इफेक्ट नहीं होगा, बिल्कुल इफेक्ट नहीं करेगा, उसका कोई यूज नहीं होगा बेसिकली. या इधर इट इज नेगेटिवली इधर इट इज पॉजिटिवली चार्ज. उसका मैकेनिज्म ही ऐसा होता है. हाँ जी. स्टिल सम स्टूडेंट्स आर ज्वाइनिंग. Bhavya S. Kumar. What are the possible sources of contamination in preparation of nanoparticles? So the possible source of contamination. See, there are different types of synthesis of nanoparticle. If in case we are preparing chemical synthesis through chemical synthesis, so there are some less chances of contamination. If in same case, if we prepare biological synthesis through biological process, in biological process we use plant extract, fungi extract, bacterial extract. So उन केसेस में कंटामिनेशन के चांसेस बहुत ज़्यादा रहते हैं. वो उसके सोर्सेज रहते हैं. हम बैक्टीरियल एक्सट्रैक्ट यूज़ करेंगे, फंजाई एक्सट्रैक्ट यूज़ करेंगे, प्लांट एक्सट्रैक्ट यूज़ करेंगे, तो उसमें बहुत ज़्यादा कंटामिनेशन के चांसेस रहते हैं विद रिस्पेक्ट टू फिजिकल और केमिकल सोर्सेज लाइक आप रूम टेम्परेचर प्रॉपर क्लोज रहना चाहिए जहाँ पे बना रहे हो. इट शुड बी नीट एंड क्लियर. यही सोर्स ऑफ कंटामिनेशन होता है ज़्यादातर. बाकी तो दिस नो सच कंप्लायंसेस ऑफ कंटामिनेशन. कंटामिनेशन एफटीआर से पता चल जाता है पहले ही स्टेप पे. गॉट इट. भाव्य एस कुमार. थैंक यू. Anybody else? So I'll share you one link that this presentation is there with proper explanation of all the principle and all the characterization types of particles. So wait.
Sir,
हाँ जी.
good evening, sir. Sir, I have one doubt.
हाँ जी please.
So, if we are preparing the nanoparticles from the plant extract, usually those nanoparticles are said to have this antibacterial,
You're
antimicrobial
not
activity.
completely audible, Bhavya. Can you please speak loudly? Or you can ask your question in chat box.
Sir, am I now audible?
And now you're audible.
Sir, when we prepare nanoparticles from a plant extract, usually these nanoparticles are said to have antimicrobial activity.
हाँ जी.
So, I was just confused about this bacterial contamination about during the synthesis.
Of plant through plant
Can you
extract.
explain? Yeah, from plant extract.
Okay,
So,
plant
can you
extract.
explain a bit more?
हाँ, प्लांट एक्सट्रैक्ट में एक्चुअली क्या होता है कि जैसे कोई भी प्लांट एक्सट्रैक्ट है उसको हम फिल्टर करते हैं. प्लांट एक्सट्रैक्ट से हम यूजुअली सीधा नहीं बनाते, सीधा रिड्यूस नहीं कराते कोई भी नैनो मटेरियल है, कोई भी कंपाउंड है, डायरेक्टली रिड्यूस नहीं कराते उसको. सो उसको प्लांट एक्सट्रैक्ट को देयर आर सम सर्टेन स्टेप्स ऑफ फिल्ट्रेशन ऑफ दैट प्लांट एक्सट्रैक्ट. उस प्रोसेस में फिल्ट्रेशन की प्रोसेस में कंटामिनेशन आता है. इफ़ यूज एनी यूज सिरिंज फिल्टर यूज्ड कोई पाइपेट यूज कर लेंगे तो उसमें कंटामिनेशन के चांसेस बहुत ज़्यादा रहते हैं. इस तरीके से प्लांट एक्सट्रैक्ट में कंटामिनेशन आता है फिल्ट्रेशन के टाइम पे. इसके अलावा फिल्ट्रेशन के बाद रिड्यूस करते टाइम देयर इज नो कंटामिनेशन थ्रू प्लांट एक्सट्रैक्ट. गॉट इट.
Yes, sir. Thank you.
ओके. So I'll share one link with a YouTube link and that this presentation is there. Just give me some. So meanwhile, if you have any doubt, you can ask in chat box.
Sir, I have asked one question.
Hanji, you can ask in chat box. Your voice is not that audible.
Sir, the question I have asked in chat box.
Hanji, you're not audible. हाँ मुस्कान.
Sir, in chat box, I have asked one question.
Does in all biological processes contamination only happen during filtration only not in other process? बाकी प्रोसेस में भी होता है लेकिन चांसेस बहुत ज़्यादा कम रहते हैं. हेलो मुस्कान, बाकी प्रोसेस में भी कंटामिनेशन होता है लेकिन जो बायोलॉजिकल प्रोसेस में बहुत ज़्यादा चांसेस रहते हैं कंटामिनेशन के as compared to physical and chemical synthesis. So this biological synthesis nowadays it goes with green synthesis. It is in trend. So इसलिए biological synthesis ज़्यादा यूज़ कर रहे हैं. इसमें contamination chances बहुत ज़्यादा रहते हैं as compared to different types of methods. Can you please explain the atomic force microscopy how it works? So in भूमिका ये सैंपल है हमारा. एक सेकेंड. ये हमने ग्लास स्लाइड पे हमने ड्रॉप कास्ट करके सैंपल दे दिया टेक्नीशियन को एएफएम जहाँ कराते हैं. तो अब एक उसमें क्या होता है, एक कैंटिलेवर होता है. ये कैंटिलेवर है, उस किसकी प्रोब है एएफएम की, और ये हमारी ग्लास स्लाइड है. इसके ऊपर हमारे नैनो पार्टिकल्स हैं. तो वो उस नैनो पार्टिकल्स के सरफेस के ऊपर वो कैंटिलेवर ऐसे मूव करेगी, उसको पूरा स्कैन करेगी टच करते हुए प्रॉपर, उसको बिल्कुल सरफेस के साथ टच करते हुए उसको स्कैन करेगी पूरे ग्लास स्लाइड को. उसकी रफनेस वहीं से पता चलेगी, उसकी रफनेस कितने नैनो पार्टिकल की, उसकी मैकेनिकल स्ट्रेंथ कितनी है. वो कैंटिलेवर सब कुछ स्कैन कर लेता है. द मैग्नेटिक प्रॉपर्टी, मैकेनिकल स्ट्रेंथ, एडिशन फोर्सेस ऑफ दैट नैनो पार्टिकल. सो ऐसे एएफएम काम करता है. सो माय क्वेश्चन इज डज इट हैपन ओनली ड्यूरिंग फिल्ट्रेशन? नहीं, फिल्ट्रेशन के अलावा और भी, जैसे हमें उसकी करेक्ट्रेशन करना है, हमें लिक्विड सैंपल से जैसे हमें सॉलिड सैंपल बनाना है, उसके लिए हम एक यूज़ करते हैं फ्रीज ड्राइंग लाइफलाइजर के टाइम पे भी कंटामिनेशन के चांसेस रहते हैं, लेकिन ज़्यादातर चांसेस उसके फिल्ट्रेशन में रहते हैं. हर स्टेप पे कंटामिनेशन के चांसेस रहते हैं, इसीलिए प्रॉपर क्लोज चैम्बर में ये सिंथेसिस करनी चाहिए आइडियली.
Sir, good evening, sir.
गुड इवनिंग.
Sir, can I ask you a question regarding assignment submission?
So I do not have any information about assignments and exam pattern.
No, sir. My question is like, what if I submit my assignment after the due date is over? Whether it will be still evaluated?
I do not have any information about this, Kavita.
Okay, sir. Thank you.
I was about to share one link. So if anybody have any doubt or any question, meanwhile they can ask in chat box. Think what is green synthesis? ग्रीन सिंथेसिस बेसिकली हम आजकल जो भी बायोलॉजिकल सिंथेसिस से हम नैनो पार्टिकल्स बनाते हैं उसको ग्रीन सिंथेसिस नैनो पार्टिकल्स बोलते हैं. अगर किसी नैनो पार्टिकल सिंथेसिस में नैनो मटेरियल सिंथेसिस में प्लांट एक्सट्रैक्ट्स या कोई बायोलॉजिकल चीज यूज हो रही है तो उसको हम ग्रीन सिंथेसिस बोलते हैं. नैनो ग्रीन सिंथेसिस ऑफ नैनो मटेरियल, ग्रीन सिंथेसिस ऑफ नैनो पार्टिकल्स, ऐसे. अगर कोई भी बायोलॉजिकल चीज लिविंग ऑर्गेनिज्म यूज हो रहा है तो उसको ग्रीन सिंथेसिस बोलते हैं. इवन प्लांट्स आल्सो. माय इंटरनेट इज बिट स्लो. You're not audible. I'm sharing that link for the PPT. I've shared that link. I don't know why it is not. Am I audible to all? I've shared that link,
Yes, sir.
but I don't know why it's not. I think it is of Google Meet YouTube link. That's why it's not going. See here and can't share screen. Sorry guys, लिंक जा नहीं रहा. यूट्यूब लिंक है शायद से इसलिए जा नहीं रहा होगा. देयर माइट बी सम प्रोटोकॉल और सम ethical issues there. So in YouTube you can go and search nanoparticle synthesis, its characterization and data processing. You can get. I think some glitch is there. So I cannot share my link for now. So maybe I'll share this link in next session. Link जा नहीं रहा. There might be some issues with that link. Hanji Mubina Abdul, you can ask. Mubina, you have raised your hand. You can ask your question. Am I audible?
Yes.
So Mubina, you have raised your hand now, so you can ask your question. So for now, I cannot share that link with you guys. I think there might be some issues with that protocol or some ethical. That link is of any YouTube channel, so that's why I think that link is not getting shared. So if you guys have any doubt, you can ask now. We'll keep it session for some more time.
So, what other information do we get from Raman spectroscopy?
रमन स्पेक्ट्रोस्कोपी में भी उसके सरफेस केमिस्ट्री पता चलती है. We'll get to know about the surface chemistry of any nanomaterial of any nanoparticle. That उसमें भी ग्राफ आते हैं रमन स्पेक्ट्रोस्कोपी में भी of any specific compound, specific element or specific polymer. So from that Raman spectroscopy, we'll get to know that this particular atom, particular metal is present in that nanomaterial. Likewise, same in जैसे FTR में देखते हैं हम स्पेसिफिक पीक आती है किसी चीज़ की, वैसे ही रमन स्पेक्ट्रोस्कोपी में स्पेसिफिक पीक आती हैं किसी सर्टेन एलिमेंट, सर्टेन कंपाउंड की. How can you access previous year questions for practice? For previous year question, you have to mail to NPTEL coordinator of this course. He can only share that previous year questions. So anybody else? Can you see the YouTube channel name? NPTEL PMRF, I think. Wait. NPTEL PMRF course. This single video is there of this presentation. You can get this video from there. NPTEL PMRF courses. Only the single presentation is uploaded there. You can access from there. So if you guys don't have any questions, so can we conclude this meeting? So okay guys, thank you so much. So you guys can leave now.
Thank you,
Can
sir.
leave now. Thank you, Nasreen.
Thank you, sir.
Thank you. Thank you all.
Thank you, sir.
Thank you, Vicky.
Thank you, sir.
Thank you, Kavi
Thank you, sir.
Bharti.
you.